Yeah, okay. Thanks a lot, Lisa. Seismologists are saying the next big earthquake isn't an if, it is a when. And in the Bay Area, they have a good idea where it will strike, the Hayward Fault. This morning, Wayne Friedman has more on one of the newest tools for earthquake forecasting. It's a NASA research plane flying so high that on many days you can't even see it. Here's our Assignment 7 report.
At the corner of Euclid and Keith in the Berkeley Hills, this is one of the sights and sounds of the season.
They dig it up almost every winter for something.
When Linda Canat bought her home 35 years ago, she vaguely remembers a warning about the Hayward earthquake fault, which triggers landslides that continually change the terrain around here.
There are problems with the water lines, the sewer lines, all of that.
But those would be minor inconveniences compared with the projected 6.8 big one that is now overdue.
The Hayward Fault is ready.
Dr. Roland Bergman of UC Berkeley, just another geophysicist who reminds us that the East Bay and all of this region are living and working on borrowed time. The Hayward Fault tends to seriously rupture every 140 years. You might want to do the math on that.
The last sudden earthquake, 1868. On average, it happens every 140 years. It's exactly 140 plus 2 years later.
For that reason, Dr. Bergman has more than a passing interest in this airplane and the radar slung in a pod beneath it. It flies out of NASA's Dryden Research Center in Southern California and follows a precise 2,000-mile crisscross grid pattern across the San Francisco Bay Area, measuring the Hayward Fault.
You might compare this grid they use to the pattern you follow when you mow your lawn, but it's a lot more precise. In fact, if they had a tube in the air 10 meters across, this plane could fly through it over and over again.
And we can do it, 10 minutes later, an hour later, 2 months later, 2 years later, and it depends on how fast things are changing.
Before the flight, NASA's Tom Mace showed us the radar up close. It looks at and into the ground sideways.
We're probably able to measure changes as small as a centimeter or slightly less. So well under an inch.
From 41,000 feet.
From 41,000 feet.
They take that data to the Jet Propulsion Laboratory in Pasadena. After repeated flights, Dr. Eric Fielding can lay one set of images on top of another to track shifts along the fault line. It's so precise that it can detect the changes in Linda Canat's backyard. Those large yellow areas you see here show landslides triggered by movements of the fault.
The thing that we're looking at on the Hayward Fault is that parts of the Hayward Fault are sliding all the time. So those parts are the parts that are not likely to break in an earthquake. The other parts of the fault are locked and building up stress. And it's those parts of the fault where the earthquake will rupture at some time in the future.
Among them, Memorial Stadium on the UC Berkeley campus.
So the Berkeley Stadium is right on the fault line, yeah.
And right through the length of the field. It's the reason UC Berkeley has begun a $300 million renovation. And it explains all those unnerving cracks you'll see if you look closely at the interior structure. They call this fault creep.
That's the stadium moving.
I could stick my hand in there.
That's right. I mean, the stadium can't really compete with natural forces, so the fault is just steadily shearing it apart.
Which is hardly reassuring for season ticket holders, but for the record, data shows the Cal student section to be safer than seats on the west side, which are built on fill.
So get your seats over on this side.
Well, that's the Cal side.
That's right. Maybe that's right.
The visitors sit on the other side.
And I was told that the Stanford section is right where the fault cuts through. I don't know if that's true. I haven't been to the big game, but...
The holy grail in earthquake studies would be to reach a point of accurately forecasting them. For now, we're still a long way from there, but much closer than ever before, even if the best, most close-up view comes at 600 miles an hour and 41,000 feet. From Berkeley, Wayne Friedman, ABC7 News.
Don't go away.